Hello students. Previously, we learned the rules of nomenclature and how to name a few hydrocarbon compounds. We also learned that in case of higher hydrocarbons, the names are given along with the numbers. These numbers indicate the position of the bond or functional group. For example, we saw that triple bonds were present on the respective carbon atoms of 1-butyne and 2-butyne. I told you to remember that we always pick the lowest number for a branch or a functional group or a bond to represent their position. For example, look at this compound. In this compound, what will be the parent chain? This one or this one? Yes, you are right. It will be the first one. This is because counting the first way, we get 4 carbon atoms in the chain, and counting the second way, we get 3 atoms in the chain. And since we know that to make it a parent chain, it should have the highest number or maximum number of carbon atoms. So what will be the root here now? Yes, it will be but, since this parent chain has 4 carbon atoms. Now let's fix this suffix here. As all the bonds are single covalent bonds, they will have the suffix "ane", which means it belongs to alkane compound. Now what about this branch present here? As you know, the names of the branches are always added as a prefix. We should fix the prefix here now. Look at the branch. How many carbon atoms are there? Yes, only one. Thus, this is an alkyl group having 1 carbon atom. What is the name of such an alkyl group? It's methyl. But wait, along with the prefix, we also have to give a number to this alkyl group. So let's count the number of this carbon on which the alkyl group is present. From the right, it will be 3, and from the left, it will be 2. So we take the lower, that is 2. Now put all these together to get this scientific name. First is the number, which is the location of the branch, that is 2, on which methyl group is present. Next is the prefix, which is the name of alkyl group, that is methyl, and then root and suffix sequentially, which gives the name 2-methyl-butane. Now what if I replace one hydrogen here with the alcohol group? Yes, it can be joined like this. In this case, the suffix will change as the functional group is changing, and the remaining portion of the name will remain the same. Now what about the suffix for alcohol? Yes, it is "ol". So the suffix "ane" will now change to "ol". So what will be the name then? Yes, it will be 2-methyl-butanol. Note that here alcohol group is present on the last carbon, which is why it reaches the number 1, and we have not mentioned it. This name can also be written as 2-methyl-but-1-ol, where 1 is the location of alcohol. Students, this way is convenient when the alcohol is present on some other carbon atom. But both these ways are correct ways of writing the name. It's just simple that this makes it easy to write the name when functional group is present on any other carbon atom. Now what about this compound? Compared to our previous one, this one is easy, right? Yes, so let's name it. Which is the parent chain here? This one with 2 carbon. So the root word will be eth. Now tell me what will be the suffix. Yes, it will be "ane", as all the carbon-carbon bonds are single covalent bonds. So the name will be ethane. Is that so? No, that's not right, because there is one more functional group present here. What about it? So we need to still name it further. Do you remember While studying nomenclature rules, we told you that the name's suffix would be divided into two parts, the primary suffix and the secondary suffix. The primary one indicates the kind of bond and the secondary one indicates the functional group. So what will be here as per this rule? Correct. The primary one will be ane for alkane and secondary suffix will be -ol for the alcohol functional group. Therefore, as the last hydrogen here is displaced by OH group, that is alcohol group, the name of this compound will be ethanol. Again, it is eth plus ane plus ol. Again, it can also be written as ethyl alcohol, which shows that this is also correct. It simply means that one H atom is removed from alkane ethane to form the corresponding alkyl group ethyl, and the alcohol replaces this hydrogen here. Now let us take another functional group. Let's take aldehyde group. What will be the name of this compound? As we see, the number of carbon atoms in this structure is 4. So here, the root word will be bute, isn't it? Yes. And the primary suffix will be ane, as they all have single covalent bonds. What about the secondary suffix? Yes, it will be al for aldehyde functional group. Thus, the name of this compound will be bute plus ane plus al, that is butanol, or simply butane aldehyde. Now look at this structure. Is it same as this one? Will it also be butanol? Yes, it will be. Here there is just a change in position of the aldehyde group. In both the cases, they are at the ends, isn't it? Yes. Or let me say it this way, in both the cases, the functional group is present on the first carbon of the chain, and thus name is same for both of them. Now let us consider the carboxylic group. The number of carbon atoms in this structure, as you see, is 6. So here the root word will be hex. Also, this compound contains all single bonds and functional group carboxylic acid. Hence, the primary suffix will be ane for alkane series and single bond, and the secondary suffix will be oic acid for carboxylic group after the root. Thus, the name of this compound will be hexanoic acid. Now look at this structure again. This is also same hexanoic acid compound just like our previous one. Here also, the position of the functional group has changed the side. So in both of them, they are at the ends, that is on first carbon of the chain, and hence the name will remain same. Student, this compound that you see, hexanoic acid, has a common name as well. It is called as caproic acid, which is used for various industrial purposes and in laboratories. This is just like ethanoic acid, which is also called as acetic acid commonly. Now look at this structure. Which is the functional group here? Yes, it is the ketonic group. How many carbon atoms are there in this compound? There are 3. So the root will be prop and the primary suffix ane for all single covalent bonds and on for the ketonic functional group. Thus, the name of this compound will be propanone. Now, what about this compound? What will be its name? Yes, it will be 2-butanone. Now, this is because the ketonic group is present on the second carbon in the chain. Can you think of another name for it? Yes, it is methyl ethyl ketone. Yes, that's right. Here, as you see, the ketone group is flanked by 2 alkyl groups on either side. One is with 1 carbon called methyl and the other is with 2 carbon called ethyl. You already know that the names of alkyl groups are derived from their corresponding alkanes. as they are formed from them after one hydrogen is removed. So 1H is removed from methane and ethane, and the respective methyl and ethyl groups are formed. And they are now bonded to the cationic functional group on either side like this. As a result, the name will be ethyl methyl ketone. Now we know that ketone group will always have two identical or different alkyl groups on either side of it. Just like in propanone, we had two methyl groups on either side. And that is why propanone is also known as dimethyl ketone. This means it has two methyl groups flanked on either side of the ketone. Or in second, we have one side ethyl and other side methyl. And therefore, cationic group will never be at the end. It will always be in the middle of the chain. So students, so far we have seen rules for naming the organic compound and how to name them. This is all about the nomenclature of hydrocarbon compounds with functional groups. In the next video, we will learn one more interesting concept, homologous series.